Is that the sample standard deviation?
But look, let's read. Is the best point estimate of the population mean.
Is the sample mean?
Correct. Is that okay? It's the X bar, right? So let me stop sharing. So it's the X bar, the sample mean. Okay? Is that everyone okay? I don't expect you to understand everything at once, so it's okay. It's okay if you say I don't know or you make a mistake. It's okay. So do we understand why it's the sample mean? Because we're talking about the population mean. Now, if I have here population standard deviation, yes, I will have to use the sample standard deviation, but it says the population mean. Is that okay with everyone?
Yep.
Okay, perfect. Who would like to read this one?
I can read it.
Okay.
To construct a confidence interval about the mean population from which the sample is drawn must be approximately normal. This statement is...
Okay, so now this is a little bit tricky, right? Because if the sample size is at least 30, it doesn't matter, as we know. So let's see what they want. They want true or false. So to construct a confidence interval about the mean, the population from which the sample is drawn must be approximately normal. So it doesn't have to be if I have a large sample. So I don't think that that this question is nicely stated, to be exact. Okay, so I'll write true, but it doesn't have to be. Okay, you answered true, so that's what I said, but it's not correctly formulated. The answer true. The correct answer is false, since the population does not need to be normally distributed if the sample size is large. Yeah, but it doesn't say. Right? That's exactly what I said. So, okay, let's try again. Okay, it's false. Okay, to construct a confidence interval about the mean, the population from which the sample is drawn must be approximately normal. So it's false, but it should mention something about the sample size. But I guess we already discussed that. So good. So let's read the next one. Who would like to?
I can read it.
Okay.
Wait, is that Gavin? Gavin can go.
Okay. The procedure for constructing a confidence interval about a mean is blank, which means minor departures from normality do not affect the accuracy of the interval.
Right. So we call that robust. So the procedure for constructing a confidence interval about a mean is robust, which means minor departures from normality do not affect the accuracy of the interval. Okay, so it's like the median. The median, if we compare the median and the mean, we know that the median is robust, right? In other words, the mean is not pulled left or right if the distribution is skewed. The mean is. So this procedure, now this is very well formulated in my opinion. Very well formulated. It says, which means minor departures from normality. So it explains, right? Which means minor departures from normality do not affect the accuracy. True. Okay. Which of the following is not a property of the student t distribution? So let's discuss that. So the student t distribution has a mean of 0. We accept or not?
Except.
Yes, we know that. It's like the z, that part. Student t distribution has the, so it's not a property, so I cannot choose that. Let's see B. The student T, it's called student T distribution. He didn't want to use, when he invented it, he didn't want to use his name. He just named it student T distribution. Has the same general symmetric bell shape as the standard normal distribution. That is true, but it reflects the greater variability that is expected with small samples. That is true. Okay, let's see the next one. The student T distribution is different for different sample sizes. Yes, because it depends on the degrees of freedom. If the sample size is 5, degrees of freedom 4. If the sample size is 10, degrees of freedom 9. The standard deviation of the student T distribution is S equals 1. No. This is the only one that does not apply. Z has 0, 1, but T does not. Has 0 for the mean, but not 1 for the standard deviation. It depends on the sample size. Okay, moving on. Who would like to address this one?
I can do it.
Thank you.
The number of degrees of freedom
Of
for a
course.
collection of a sample is the number of sample values that can vary after certain restrictions that have been imposed on all data values.
Exactly. Only the degrees of freedom, only 9 minus 1 or 10 minus 1 have freedom. The last one does not. Well done. Okay. Again, the same thing. They give a sample and they put this uppercase N in here. Okay, careful. Who would like to start this one?
I'll start it.
Thank you.
The study asked respondents, if ever married, how old were you when you were first married? The results are summarized in the technology excerpt that follows. See parts A through D.
Perfect. So, anyone has an idea about the point estimate?
I do.
Yes. Ready.
Point estimate 22.6.
Excellent. Great job. What about the margin of error? Is that tricky definition of standard error of the mean? Right? So that is sigma over the square root of n. But what we need is the margin of error, which is given to us by the interval, the confidence interval, which is the difference between the mean and the top, or the difference between the mean and the bottom. Yes. So it's either 22.705 minus, right?
Isn't it? Yeah.
So 22 points minus 22.65. What did you get? 0.055?
Yes.
Excellent. Thank you. That's it. Well done. Okay, so let's interpret. The confidence interval is right here. And remember, the key word is the word confident. If it does not have the word confident, or whenever we explain what the confidence interval is telling us, we have to use the word confident. I am 95% confident. So either this or this. Okay, either B or C. So now let's read it. Who would like to give it a try?
I can.
Yes.
One can be 95% confident that the mean age of people first married is between 22.595 and 22.705 years. You put an extra 5.
I know. I was all wrong. And 22.705. Excellent. So this one makes no sense, right? It's an interval. So what we are saying here is this. I am not 100% confident and not 50% confident. I am 95% confident that the true mean population, mean age of people, the true one that I don't have, but I'm 95% confident that it lies between 22.59 and 22.705. Okay, that's what it means. Okay, so now they're asking us to enter the information in here to determine the lower bound. So we have to determine this number. I can put it in already. It has to be 22.595. But how do I get it? I have to start with a mean, right? So let me stop sharing for a second. I have to enter this. Margin of error, which we already determined it as being 0.055. And the top, the upper bound, the mean plus that number. So I have to enter the mean, which is 22.65. And I have to put the minus because that's the lower bound. I have to put here the sample size, which is 26770. And I have to determine the critical number for 95%. And I stop and I go to my calculator, and this time I need inv-t. Inv-t. Not all calculators have it, however, be careful. Okay, so the area to the left, because I want 95, right? It was a 95% confidence interval. So then the area to the left is 0.025. 0.025, the area to the left, degrees of freedom. How do I determine that? I have the sample size. So the degrees of freedom will be 26779. Because this number is so big, you will see it makes no difference if I use the z distribution or the t distribution. But I have to enter 26769. 26769. And calculate. And it will give us, as you see, 1.96 like for the z distribution, because it makes no difference. It's such a big number. So where am I? So I will enter 1.96. And that checks. And the other one will be identical, but with plus. So 22.65. And then I have plus. And yes, 1.96. The higher n, the closer it becomes to z. So 2.6.
Professor, you forgot to put a decimal on the 1.16.
I forgot. Yes, thank you. Thank you so much. So this was 22.65. Thank you so much. And I have to copy 22.705. And okay, so now let me show with the graphing calculator also. And this is a t interval. I didn't mean that. No, I didn't mean that. I meant this. Tests. So I want a t interval, number 8. So number 8. So I went with statistics. I want x bar, which was 22.65. A sample size, what was it? 26,26770, yes. and 95% confidence. And now I have to check and find the standard deviation. What was the standard deviation? 4.601. 4.601. And now when I click enter, we have to get that interval. It has to be identical. So where is my enter? Enter, enter, calculate. 22.595 and 22.705. Okay, exactly what they have here. 22.595 and 22.705. So T interval. Okay. There is part D. Why is the margin of error for this confidence interval so small? Okay. What do you think?
Would it be because the sample size is very large?
Absolutely. The sample size used is very large. Yes. So that's why the margin of error is this number, all this product here, and we determine it to be 0.055. 0.055. Yes, absolutely. Thank you. Good. So let's continue. Who would like to